Hello, this is Dr. Farhana Shaheen. Today we are going to talk about trigonometric identities, which are related to sine theta, cos theta, and tan theta, along with cosecant theta, cotangent theta, and secant theta. So these are the basic identities we are going to talk about. Reciprocal identities, cosecant theta is equal to 1 over sine theta, secant theta is equal to 1 over cos theta, and cotangent theta is equal to 1 over tan theta. Quotient identities are tan theta equal to sine theta over cos theta, and cotangent theta is equal to cos theta over sine theta, because cotangent theta is the reciprocal of tan theta. Similarly, we have Pythagorean identities. Sine square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta, and 1 plus cot square theta is equal to cosecant square theta. So we are going to study from where we got these identities. Now, to discuss these basic identities, we need to go back to our right triangle where we learned about psoa quadrata. We all know what that is. Sine theta is opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. Now, what if we fix this right triangle into a unit circle so that the hypotenuse of the triangle becomes the radius of the circle, and a unit circle is a circle with radius 1. So now our opposite is y, adjacent is x, and hypotenuse is 1. So keeping in mind, we are gonna take this point as P. Say P is a point xy. Now, we all know that sine theta is equal to opposite over hypotenuse. So in our case, if we take this as theta, then sine of theta will be equal to y because r is 1. Similarly, cos theta is equal to adjacent over hypotenuse, so cos theta will be equal to x. Now using Pythagorean theorem, we have x square is equal to x square plus y square. So in our case, we will have cos square theta plus sine square theta is equal to 1 because the hypotenuse is equal to 1. Now what if we divide both sides by cos theta, cos square theta? Using the reciprocal identities and the quotient identities, this will convert to 1 plus tan square theta is equal to secant square theta. So from the first Pythagorean identity, we now have another one, which is 1 plus tan square theta is equal to secant square theta. Now, what if instead of dividing by cos square theta, we divide the whole identity by sine square theta? So we'll have cos square theta plus sine square theta equal to 1, and we are dividing by sine square theta on both sides. Now using the reciprocal identity and the quotient identity, we'll get cos square over sine square is cot square theta. So we'll have cot square theta plus 1 is equal to, we know 1 over sine is cosecant, so it will be cosec square theta. And that's how we get the third identity. Now, from these three, we can make 6 more. For example, from the first one, if we take sine square to the other side, we'll have cos square theta is equal to 1 minus sine square theta. And if we take cos square theta to the other side, we'll have sine square theta is equal to 1 minus cos square theta. Similarly, from the second one, if we take tan square theta to the other side, we'll have secant square theta minus tan square theta is equal to 1. And if we take 1 to the other side, we'll have secant square theta minus 1 is equal to tan square theta. Similarly, we can do the same with the third one. Taking cot square to the other side, we will have cosecant square theta minus cot square theta is equal to 1. And taking 1 to the other side, we will have cosecant square theta minus 1 is equal to cot square theta. So it's very difficult to remember all these 9 identities. But the best way is, to begin with the first one, and you can make all these 9 according to the situation. So this is how we begin with, like we discussed, and we can make many, many more. Thank you.